99% of developers don't get Git Rebase. Sure, every intern learns the classics: Git add, Git commit, Git push, and copious amounts of Git reset hard. Because you're an intern, and taking down prod is a rite of passage, right? It reminds me of that satirical Reddit post during a major Facebook outage where someone joked that they'd pushed their first change at their internship. Never gets old. But think about it, using a tool every single day without understanding one of its most powerful features. I'm not even talking about Git cherrypick or Git stash, which definitely have a lot of utility the more you use Git. I'm talking about Git Rebase, a command so controversial that many developers are told to avoid it like the plague. But on the other hand, Sydney Sweeney seems to be a die-hard Rebase fan. How can you label it as bad practice if you don't even know what it does? Do you even know the difference between Git merge and Rebase? Let's pull back that curtain on the foreign, infamous, abstract Git Rebase concept from a 10,000-foot view, and then dissect some of the more critical details to see what makes it so powerful, yet so feared. Let's dive in so you can finally understand this meme. What is a Git Rebase? Git Rebase is a Git command used to move or replay a sequence of commits from one branch onto another. In simple terms, it rewrites the history of your branch by pretending your work started from a different place, a different base. Instead of merging two branches together, which creates a new merge commit to combine histories, Rebase transplants your commits as if they were created on top of the latest state of another branch like main or master. This makes the branch look as if you had pulled the latest changes before starting your work, even if you actually didn't. The command fundamentally changes the parent commit of each rebased commit, meaning although the content may be the same, the commit hashes are entirely new, which you'll see has important consequences. Okay, but hold the phone. Why is Git Rebase useful? Rebasing is most commonly used to clean up commit history, sync your branch with the latest upstream changes, or make your feature branch look like it was developed on top of the latest main branch. This makes the commit log more linear and easier to follow. Instead of a history with forks and merges, Rebase can give you a straight line of commits, showing a clear progression of work. A clean, linear history is especially valuable in large teams or open source projects, where reviewing and auditing changes becomes easier when there aren't dozens of tangled merge commits. Teams often recommend rebasing before merging into a stable branch to simplify Git history and reduce noise. But turns out this practice is actually very controversial. What actually happens during a rebase? Conceptually, Rebase works in three major steps. First, Git identifies the common ancestor between the branch you're on, for example feature X, and the branch you're rebasing onto, for example main. This is where your branch forked from main, and this is called the merge base. It represents the last shared commit before the branches diverged. Second, Git finds all your commits after that base, the ones unique to your branch after that common ancestor, and temporarily removes them, saving them as patches in memory. Finally, Git switches the branch pointer to the new base or tip of the target branch, for example main, and reapplies or replays each saved commit on top of it. This creates entirely new commit objects with new hashes. The reason there are new hashes is because each one now has a different parent and the base has changed. In essence, Git is not moving commits, it's copying and rewriting them, creating new versions. That is why Rebase alters history. The resulting commits are technically new and different from the originals. Okay, but you could say, Coding Gopher, you're being way too abstract. We're not trying to be Picasso here, so let's walk through a concrete example. Let's say your history looks like this. Now, someone adds commit G to main, and you want to rebase your feature branch. If you run git rebase main from feature X, Git will 1. Find the common ancestor, commit B. 2. Set aside your commits D, E, F. 3. Move your branch pointer to G, the latest on main. And 4. Reapply your commits D, E, F one by one on top of G, which results in this. Now pay attention closely. D', E', and F' are not the same as the original commits. They are rewritten versions with different hashes, even if their changes are identical. This new linear history makes it seem like your work was done after G, even though it was originally done in parallel on a separate branch. Note that there is not a single merge commit, which is different from git merge. Diving into the Git Kraken UI, we perform a rebase from the 11.2 feature branch into the dev branch. The result of the rebase is a clean linear commit history. As you can see, the rebase was successful. You might be asking, Coding Gopher, how does Git Rebase compare to Git Merge, which also combines branches? Well, young one, let me tell you. The difference lies in how history is preserved. Git Merge keeps the original branching structure and adds a new merge commit to tie together the histories. This makes it non-destructive and safe for shared branches. But the resulting history can be very noisy, especially in long-running branches. Git Rebase, by contrast, linearizes the history by replaying commits, which is cleaner but comes with the cost of rewriting commit hashes. Remember, merge is additive, rebase is reconstructive. Let's just assume that your TikTok brain still cannot comprehend, so here's the TLDR. Use Git Rebase when you want to 1. Keep history clean and linear, 2. Incorporate the latest changes from another branch without a merge commit, and 3. Prepare your branch before merging, for example rebasing before a pull request. And use Git Merge when you want to 1. Preserve the true history of development, 2. You're working in a shared branch and want to avoid rewriting history, and 3. You don't mind having merge commits in the history. Personally, I'm on the fence. It's a case-by-case basis for me. Jumping back into Git Kraken, when we explicitly merge the 11.2 feature into the dev branch, we see that a merge commit has been created in the visual graph, and the independent branch history is preserved. Rebase versus merge is extremely controversial, so let's talk about the danger zone of rebasing and shared branches. Because Rebase rewrites commit history, it comes with a crucial rule. Do not rebase commits that you've already pushed to a shared or public branch, unless everyone involved understands and agrees to it, and you're absolutely certain no one else is using them. But coding Gopher, why? Because rewriting history by rebasing and force pushing means your commits now have different hashes, and other collaborators who base their work on the old history and original commits will now face conflicts or lose work. So as a rule of thumb, it's okay to rebase local feature branches. This is because you're essentially working in your own sandbox. Changes are not yet shared with others, and rewriting history is okay. Use Git Rebase to make it cleaner, combine commits, or remove mistakes. Since nobody else is relying on this specific history, it's not going to cause any problems. But it's very dangerous to rebase to main, shared, or public branches. Remember that these are shared resources. The main branch or other shared branches like dev is a central point where multiple devs collaborate. It's a shared history of committed code. Don't tamper with it. If you do rebase a branch you've already pushed, you'll need to run git push force or force with least, which is a safer option that will not overwrite any work on the remote branch. Force pushing a rebased branch essentially tells Git to overwrite what is currently on the remote regardless of what others have done. This can and probably will disrupt teams and CI systems. So the TLDR is rebasing is generally safe only for local personal branches, not collaborative ones. There's this other very powerful feature called interactive rebase, or Git Rebase with the I option. It's one of the most flexible features of Git Rebase known as interactive mode. This gives you full control over the commit history and allows you to reorder, squash, for example combine, edit commit messages, drop or delete commits, or split commits into smaller parts. You run it like this. This allows you to interactively edit the last 4 commits. A text interface opens showing a list of commits and actions like pick, squash, edit, and drop. You can squash multiple small work in progress or fixed typo commits into one meaningful commit. You can even pause during a rebase to make changes to the working tree and continue afterwards. This is a very critical tool for crafting a professional, polished commit history before submitting code for review. Jumping back into the Git Kraken UI, we're going to begin an interactive rebase from the conflict detection branch onto the new conflict branch. First, we start by squashing the first 2 commits. Then, we're going to reword the commit message for the cherry pick markdown changes. And then let's do a bit of drag and dropping to reorder the commits. Finally, we're going to squash a commit and drop another commit that we no longer need. Using this UI, the interactive rebase process feels actually interactive. I find that this format of an interactive rebase tends to be a lot more intuitive and less error prone than the traditional CLI-based approach. But Git rebases are not always that easy. Back in elementary school, you were either a bully or you got bullied, and you had to talk about conflict resolution. Well, unfortunately, or perhaps fortunately, we also have to talk about conflict resolutions when it comes to rebases. During a rebase, conflicts may occur when a commit you're replaying doesn't cleanly apply to the new base. Git will pause and present a conflict marker in the files involved. You need to manually resolve the conflict by editing the file, marking it as resolved with git add file, and continuing with git rebase continue. If things go very badly or you change your mind, you can just run git rebase abort to cancel the entire rebase and return your branch to the original state before the command began. This is possible because Git saves the pre-rebase state in the ref log, allowing you to roll back safely. I find resolving merge conflicts to be a pain in the butt, so let's use AI to speed up this workflow. There's a conflict in the mkdocs.yaml file, so I head over to the Auto Resolve with AI preview feature. It provides some solid suggestions for the 3 conflicts found in the file, along with confidence percentages. Of course, be cognizant as a human reviewer and use your best judgment to either accept or reject the AI-generated suggestions. I recommend incorporating this into your dev workflow because merge conflicts are honestly a source of a huge amount of toil. Alright, because you made it to the end and your brain survived the rebase, I've got something for you. Here are 2 bonus Git commands that might not sound flashy, but they will save you. Git Stash, also known as save now, commit later. Imagine this, you're halfway through building a feature, nothing's committed yet, things are broken, and suddenly you need to switch branches, pull the latest from main, or fix a hot production bug. but you can't commit yet, it's not ready. But at the same time, you don't want to lose your work either. All you have to do is run Git Stash. This clears your working directory, your changes vanish. But don't worry, Git secretly stores them in a stack-like structure. If you want them back, run Git Stash pop. That restores the most recent stash and removes it from the stash list. Let's say you want to restore the most recent stash, but you want to keep it in the stash list just in case. Then you can run Git Stash apply. The TLDR is that Git Stash temporarily shelves or stashes changes you've made to your working copy so you can work on something else, and then come back and reapply them later on. Stashing is handy if you need to quickly switch context and work on something else, but you're midway through a code change and aren't quite ready to commit. So what exactly gets stashed? First, modifications to tracked files, and second, staged changes. What doesn't get tracked are untracked files unless you use the include untracked option. Files are untracked when they've been created in the working directory but haven't been added with git add. For absolute full coverage, run git stash with the U flag. You can even name your stashes for clarity. Git stash save, work in progress, fix navbar alignment bug. With Git Kraken, there's an AI-powered stash summary generator. Instead of you manually naming or guessing what was in the stash, the AI looks at the diff and generates a clean description for you. It's like version control, but smarter. Now let's talk about one of my absolute favorites. Sure, I occasionally consider myself God's gift to mankind when it comes to coding, but I still do make mistakes. And that's where Git Commit with the amend option comes in handy. It's a time travel for your last commit. Alright, now let's say you just ran Git Commit add login feature, and then suddenly you realize that you're only human. You forgot to add the auth.js file, or perhaps your commit message was a typo, or worse, it just says git commit stuff. Remember, this is a production ready repository. No sweat though, just amend it. Git add auth.js and then git commit amend. That reopens your last commit and lets you add files, edit the message, or both. The resulting commit replaces the old one as if the mistake never even existed. If you just want to change the message, run git commit amend, add login feature with OAuth 2 support. But here is a quick heads up. Amending actually rewrites the history, so only use it on local commits you haven't pushed yet. If you've already pushed, you'll need a force push, which can be risky if others are working on the same branch. Git Kraken's AI commit assistant gives you message suggestions based on your diff. So if you're amending and don't want to think about phrasing, it'll draft something intelligent for you. You can think of it like spell check, but for commits. But remember this, I'm the Coding Gopher, a self-proclaimed coding prodigy, and I want to enlighten you with a couple best practices when it comes to pull requests. I've reviewed thousands of PRs over the years and I know exactly what makes an immaculate PR. So once your local commits are ready and pushed, the next step is opening a PR. But how you do it matters. First, keep your PRs focused. Ideally, one PR should address one logical change, a bug fix, a new feature, a refactor, not all three. This makes code review smoother and rollback easier if needed. Second, always write clear commit messages. A great rule of thumb, your commit message should complete the sentence. If applied, this commit will fill in the blank. For example, fix login redirect bug when user has expired session, or refactor cart service to reduce DB load by batching queries. Avoid vague messages like update files or stuff. If you're using Git Kraken, it comes with an AI-powered commit message generator that works beautifully with your PR workflow. After staging changes, Git Kraken analyzes your diffs and auto-generates a commit message that's clean, descriptive, and aligned with common best practices. Whether you're tired, in a rush, or just not in the mood to write yet another immaculate commit message, this feature saves you time and keeps your history tidy. It's especially useful for multi-file changes where summarizing everything manually is a pain. You always have the liberty of tweaking the AI's suggestion before submitting. If you learned something new in this video, consider leaving this video a like and subscribing for more future content like this. As always, thank you very much for watching this video and happy coding.